Hi, this is Roopa Prasad, MCA, Assistant Professor, MCA, MITS College, and we are going to discuss about the topic called as page replacement. So these are the contents that we are going to discuss today. So first we discuss about the approach of page replacement. Then we go for the basic concepts of page replacement. Then we go for discussing the page replacement algorithms. In that we discuss about the FIFO page replacement, optimal page replacement. Finally, we go for the LRU page replacement algorithms. Coming to the basic approach of page replacement, actually there is a technique that we have discussed, what we call it as a virtual memory technique, which allows the execution of a process that is not completely in the main memory. So what happens, the process will be allocated in the process will be loaded in the hard disk. So few pages will be allocated in the main memory. And the CPU is going to execute the process. So it is going to refer the logical address. That is a page number it is going to refer. So that page number will be searched in the page table. Okay. If that page is not available, then what happens? Operating system has to brought this page, desired page into the memory for execution. Suppose think that if there is no free frame allocated, then we have the concept of the page replacement. That means what? The page that is already available in the physical memory that it will not be in use, that has to be replaced. That means that page has to be paged out, that is swapped out from the memory, and the required page has to be swapped in. That is the page replacement approach. This is the basic approach of page replacement. Okay, so this page replacement is a basic to demand paging. So what is demand paging? Demand paging means the page will be brought into the memory only when it is required for execution. And this virtual memory can be implemented by using demand paging. For this demand paging, this page replacement is a basic. Okay, so what the demand paging is going to do means it separates the logical memory from the physical memory so that there is no bound of the programmer need not to be think of the physical memory. Okay, so this can be completed by using the concept of page replacement. Okay, so what happens, for example, consider user process is having 20 pages, so we can execute it in 10 frames only. That means for that process 10 frames can be allocated. That means we are going to store only 10 pages in the main memory and remaining 10 pages will be in the hard disk. Whenever the page is required, that will be brought into the memory. If that 10 frames are completed, now we have to replace one frame, one page that is in that frame, that with the new page. There we require the replacement. So in order to implement this demand paging, so what the operating system has to consider is it has to consider two algorithms. One we call it as a frame allocation algorithm, and next one we call it as a page replacement algorithm. Frame allocation algorithm means it is a multi-process programming. That means what? Multiple process will be in the memory. So we have to allocate frames for each and every process. There the operating system has to execute the frame allocation algorithm in order to decide how many frames has to be allocated to each and every process. So when page replacement is required, that means you have to select one frame that has to be replaced. For that one, you have operating system must have appropriate algorithm to solve this problem. And there are so many page replacement algorithms are there. So every operating system has its own replacement scheme. So, which replacement algorithm the operating system has to select depends on the lowest page fault rate. That means if we use that algorithm, the page fault should be minimized. That means page fault means what? If the referenced page is not in the memory, then we call it as a page fault. So that page fault rate should be minimized. That algorithm has to be selected. So this algorithm, so there are so many algorithms are there. So these algorithms are evaluated by running it on a particular string of memory references, and this we call it as a reference string. So this reference string can be generated artificially by using the random number generated, or we can trace a system and record the address of each memory reference, which I will show you the example. For example, this is a series of address sequences that are referred by CPU. processor, that is processor. Now it is going to refer these pages. So we are going to form this reference string. And by using this reference string, we are going to evaluate the various page replacement algorithms. Now, there are so many page replacement algorithms are there, but today we discuss about the very important algorithm. These are the three important page replacement algorithms. One we call it as a first in first out algorithm, and second one is the optimal page replacement algorithm. Then finally LRU, that is a least recently used algorithm. First we go one by one. So first in first out algorithm. Okay, so this is the simplest algorithm, so that we call it as first in first out. In the name itself we can say the page that is brought in first into the memory, that is going to be replaced first. Okay, so for this purpose what we require that with each page that time when that page was brought into the memory. Okay, so a page must be replaced, the oldest page is chosen. So when a page has to be replaced, the oldest page must be chosen. Okay, so for this one, what we are going to do means we are going to maintain the FIFO queue to hold all the pages. So the page that has to be replaced is taken from the head of the queue, and the page that is brought into the memory, we insert at the tail of the queue. That is called as a RAID. Okay. So this is a reference string. So at present, 3 frames has been allocated for this particular process. Assume that initially all the frames are available free only. Okay. Now the processor has given, the CPU has referred 7th page. Now 7th page is not available in the memory, so we call this as a page fault. Okay, so this is a page fault. Okay, then the page will be brought searched in the hard disk, and it will be brought into the memory for storing. So next, what is the reference? Next reference is 0. So 0 is not available. So what happens? So we call this as a page fault. This is also a page fault. So that will be brought into the memory. Next, 1 is not also available. So it is also brought into the memory. So this we also call it as a page fault. Okay, so this 7, 0, and this 1 is also a page fault. Next one, next in the sequence we have 2. 2 is the reference. Okay, now all the frames has been allocated by the pages. Okay, here becomes a page replacement. Then here we have to do the page replacement. This is the page fault, and you require the page replacement. So which page we have to replace? What page we have to replace means, according to this algorithm, the page that was first brought into the memory, that has to be replaced. So this page, the 7th page is brought into the memory first. So this 7 will be replaced by 2. Okay, clear. So next one is 0. 0 is already present, so there is no need, there is no page fault, and then there is no need for the replacement also. Next one, 3. 3 is not available in the memory, so it is a page fault, and it has to be replaced. So with which page we are going to replace? So after 7, 7 is replaced. So in the queue, which is in the head of the queue, 0. So we are going to replace 3 with 0. Okay. Now next one is 0. So 0 is not available here. So we have, this is a page fault, and we have to replace. So we are replacing 3 with 0 with 1. Okay. Like that we are going to proceed. Clear. So what this algorithm is going to say means, we are going to replace the page that is first brought into the memory. Okay. So that is maintained by using the queue. Then we go for the another algorithm. Before going to the algorithm, we discuss a small topic that we call it as a Bell-Addis anomaly. Okay, so what happens generally, if number of page frames increases, the page fault rate should decrease. Okay, that is the main thing. So for example, there is only one frame, the page fault will be 12 for this reference string. So for the if we increase the number of frames to 2, the page fault is same, that is 12. So if we increase the page numbers to 3, the page fault has decreased. That is the actual scenario. It should be the actual scenario. When we increase the number of frames, the page fault should decrease. But what happens when we increase the number from 3 to 4? Instead of decreasing, the page fault rate has increased. Actually, what happens? The page fault rate should decrease. But here, what is happening? The page fault rate is increasing. That we call it as a Bell-Addis anomaly. And this FIFO algorithm suffers from Bell-Addis anomaly. And we go for the another algorithm that we call it as a optimal page replacement algorithm. So this algorithm is considered as the lowest page fault rate of all the algorithms, and this algorithm is not going to suffer from Belladis anomaly. That means what? Belladis anomaly we have already discussed. That means what? If we increase the number of frames, the page fault should be decreased. Okay, the page fault rate should be decreased. But what happens? It increases. Sometimes it increases. That we call it as a Belladis anomaly. Okay, this algorithm won't suffer from Belladis anomaly. So what we are going to do this in this algorithm is we are going to replace the page that will not be used for the longest period of time. Is it clear? We are going to replace the page that will not be used for the longest period of time. That means what? We have to know the future reference. Future reference we have to know. First we consider this algorithm, then we say what are the drawback of this algorithm. Okay. Now all the frames are empty. Now 7 is reference, 7 is not in the memory. So that is called as a page fault, and we are going to brought into the memory. No replacement is required. So 7, after that 0, 0 is not available. So is a page fault and 0 is brought into the memory. Then 1, 1 is not available here. So it is a page fault. 1 is a page fault, and we are going to bring this into the memory. Okay. Now 2 is referred. 2 is not available. We are having only 701, but 2 is referred, 2 is not in the memory, so it is called as a page fault. Now there is a replacement has to be done. Okay, so using this algorithm, how the replacement is done, what is the basic procedure of this one? You have to replace a page that will not be used for the longest period of time. So we have to check the future reference. So what are the pages in the memory? 701 is there. Okay, so 7, when is 7 first? 7 is referred, 7 is referred here. At last we are referring 7. Then next one, what is 0? 0 is referred here only. 1, 1 is referred here. So for the longest period of time which is not going to be referred, 7. So we are going to replace 2 with 7. So here it becomes 201. Clear? That means which will not used for the longest period of time. So we have to check the future references. Okay, so next, what is the next one? 0, 0 is available here, no page fault. Then the next reference is 3, 3 is not available here, only 201 is there. That means what we have to, there is a page fault and there is no free frame available, so we have to replace. So how we are going to replace? You are going to find the page that will not be used. So what are the pages in the memory? 201. So where is 2 referred? Here it is referred. Next one 0, 0 is referred here. 1 is referred here. After 2 we are referring 1. So 1 is a victim. That is, the 1 has to be replaced. So we are replacing 1 with 3. Okay. Then is a 0, 0 is available. Then 4, 4 is not available. So we have to go for the page fault, and it is a replacement, and go for the replacement. So what page we are replacing? Now we check. So 2 is referred here, 0 is referred here, 3 is referred here. So which has not longest period used? 1. So we are so 0. Okay, this is a 2, this is a 3 is referred here, then 0 is referred after 3. So we are going to replace 4, replace this 0 with 4. Okay, like that we proceed this algorithm. And this algorithm is difficult to implement. Why? Because it requires a knowledge of future reference string. Okay, we have to replace a piece that will not be used for the longest period of time. That means what? You must know the future reference, future knowledge of the reference string. So it is somewhat difficult. It is difficult to implement. Then we go for the another algorithm that we call it as a LRU page replacement algorithm. So the main procedure we are using this algorithm is replace the page that has not been used for the longest period of time. Okay, that means what? Backward direction. We have to check in the backward. Okay, so this one, what we have to do when we have used this page last, that had to be recorded. So we are going to replace the page that has not been used for the longest period of time. Okay, now we see with this example. So this is the reference string. Okay, and 3 frames has been allocated for this process. Now our first referred is 7. 7 is not available in the initially. Think that it is not available, it is empty. Okay. Now what you are going to do is a page fault. Operating system will bring 7 into the memory. Now what is the next reference? 0. So 0, here only 7 is available. Two more frames are there. 0 is not available. So it is called as a page fault. 0 will be brought into the memory. Okay, next reference is 1. 1 is not available here. So page fault. If the referenced page is not in the memory, it is called as a page fault. Okay. So then will be brought into the memory. So now the memory is full. Okay. Next reference is 2. Okay. 2 is not available in the memory. That is called as a page fault. And what we have to do, there is no free frame also. So we have to go for the replacement. So what is the replacement we are going to use here? LRU. That means the page that has not used for the longest period of time. So check here. So what are the pages here? 701. Okay. 7 is used prior to 0, prior to 1. So longest period of time we have not used the 7. So we are going to replace 7 with 2. Okay, clear. Then the next one is 0. So 0 is already present, no page fault. Next one is 3. 3 means page fault, we have to replace. Now check. So what we have? 201. 0 is referred here, 2 is referred here, 1 is referred here. Which has not been used for the longest period? 1. So we are going to replace 1 with 3. Like that it follows. Okay. So optimal means we are going to look forward, and LRU means we have to look backward. So this algorithm can be implemented, okay, by using two things are possible. Okay, one we call it as counters. Okay, we can make use of counters. So what we are going to do means, here we are going to, in the page table, we are going to make an one other field that is called as time to use. So whenever the page is referenced, that has to be noted. The clock has to, counter has to be noted with the clock. So every time when it is referenced, the clock will be incremented. So when we have the more references, it has a more counter will be incremented. So whenever we have to go for the replacement, we check the time. So which page is having the smallest time value, that will be replaced. Okay, clear? That we call it as counter. For each page, we are going to maintain one time of use field. Okay, whenever a page is referred, we are going to increment the counter. That is counter. So whenever we want to replace, so what you are going to do, you are going to replace the page with the smallest time value, or we can use a stack. Okay, stack can also be used. So whenever a page is referenced, it is removed from the stack and put on the top. Okay, so what we are going to do, keep a stack of page numbers. So whenever a page is referenced, it is removed from the stack and put on the top of the queue. So the most recently used page will be always on the top, and least recently used will be always on the bottom. So we are going to replace the page that has been least recently used. Okay, now, so this can be implemented by using doubly linked list. So look at here. So now we are referring 4. So these are stack of pages. We have stacked in the stack. So 4, so 4, then 7, then 0. Again 7 is reference. So we are going to remove this 7 and we are placing on the top of this top of the stack. And next 1 we are placing above 7. Okay. Next 0 is moved and placed on the top. Like that we will place here. So whenever we have to replace, we are going to take the page which has been least referred. That means 4 will be replaced. 7 is not replaced, 4 is replaced. Like that we are going to execute this algorithm. Hope you understand. Okay. And these are the references. And if you have any queries about this concept, you can drop your queries here. Thank you.